to the break. First up, we have someone online, Joshua Wang. He's presenting on examining language inclusion intentions in a scoping reviews.
Great. Hi, everyone. Because of my shared screen, I can't actually make sure that everyone can hear me. Can everyone hear me and see me okay?
Yeah.
Yeah, cool. Thank you. So yeah, I'm Josh. I grew up in Brisbane, Queensland, but I'm now in Taiwan doing a postdoc. And I'm just presenting a small amount of work that I've done with my colleague, Dr. Hayley Moody. And so we're looking today at language inclusion intentions in scoping reviews. So language inclusion is definitely not something that's new to being analysed, I'm sure, by the people here. One particularly awesome paper that came out this year from UQ is by Hannah et al., looking at language inclusion in systematic reviews in fields of ecology. So there is a lot of literature published in languages other than English. A lot of my colleagues here publish in Mandarin, for example, and this work is quite important, and there's a growing debate within the meta-analysis community as to whether or not including this literature is important. However, a lot of these conversations tend to be held towards systematic reviews, and other forms of evidence synthesis haven't really been considered just yet. So what we're looking at today is scoping reviews. I'm not the expert on all the differences between systematic and scoping reviews. So if I say something wrong here, please feel free to attack me later in question time. But the general gist is that a scoping review should be a more broad form of evidence gathering. So, for example, prior to a systematic review, you might conduct a scoping review to try and identify what sort of evidence is even available, what kind of methods are being done, how is this topic even looked at or addressed. So a scoping review is often much broader than a systematic review, which has quite a defined question that you're looking for answers for. And so Hayley and I therefore considered this, and we thought, well, scoping reviews, since they're more broad, potentially there should be more of a motivation there to look at languages other than English and see what there is in that. So as a result, we did a relatively small analysis where we screened, and we ultimately found 249 peer-reviewed scoping review protocols, so published in journals that accept scoping review protocols, published in 2024. So our goal was really to get a snapshot of what the current LOE, or languages other than English, inclusion intentions are right now. And so I'll just run you through a couple of the results for that. So firstly, we found that about half of the scoping review protocols included at least one language other than English. For the LOE exclusive protocols, there was a big mix as to how they were excluded. So we did find that quite a few excluded languages other than English right at the search stage. So for example, in their search string, they would only return results that were in English. Others took an approach that's a bit more recommended, which is to search for all languages and then actually calculate how many languages other than English results were excluded later on. So excluded at the actual screening stage of things. And then a few never even addressed whether or not there were languages other than English considered. There weren't really any differences in the geographical distribution of LOE inclusive versus LOE exclusive, but I will just point out that a lot of the studies in our data set do come from Canada, which we believe is why we see French as being the most prominent language other than English that's included. For most of the LOE inclusive studies, they did only include one LOE. So there are a lot of these where if they weren't doing just English, it was English and then one other language. And then in terms of how the authors talked about or discussed, how they would go about looking at languages other than English, the most common by far was utilizing the language ability within the authorship team. So usually we were dealing with large authorship teams, and there would be a couple of people in there that could read those articles if they came up. And lastly, we wanted to look at if having author affiliations from multiple countries correlated, or if the geographical scope, so were they looking at a particular region, if they were correlated with LOE inclusion, and we got negative results for that. So we did not find a correlation there. So overall, we found that there was quite a diversity in the LOE inclusion strategies for scoping reviews. A lot of them rely on the authorship team. There was a lot less of machine translation planning going on, and that we would recommend that if languages will be excluded, that they are excluded at the screening stage, and that there is a separate document done up to show what was excluded, rather than just leaving it out at the search stage. And obviously next steps would be to conduct a larger analysis, but then also to interview the authors of these papers to try and understand the influences behind their decisions. All right, thanks everyone.
Okay, all right. So often when we talk about the replications crisis, we're often talking about it in regards to individual studies such as psychology experiments or lab-based studies. But there's been less attention focused on these issues in the evidence synthesis world, even though systematic reviews are often characterized as being inherently replicable. And so we thought it was important to evaluate the replicability of multiple steps of the systematic review process to determine where inconsistencies are most likely to occur upon replication and why. And so the aims of this study was to evaluate the variation in results following independent replication of the literature search, the screening, data extraction, and meta-analysis of systematic reviews. And this was done as part of a larger project called the REPRISE project, the protocol, which is available here. So what we did was we selected 10 systematic reviews of the effects of health interventions published in November 2020 that had to be reported quite well, perhaps even better than what's recommended in reporting guidelines, in that they needed to have presented the search strategy for each database, the number of records yielded by each search, results of the studies included in the meta-analysis, and the meta-analysis results themselves. And to make our life easier, we just limited it to reviews including 10 or fewer studies. And the study coordinator, being myself, collected all the information about these points from the original reviews and provided these to the replicators. The personnel who replicated these reviews, we had 2 information specialists or librarians who were responsible for replicating the searches, and 2 systematic reviewers who did the screening, data extraction, and meta-analysis. And each replicator performed these processes independently, and they were initially blinded to the original systematic reviews results. But then following submission of their blinded results, we then unblinded the replicators and allowed them to look at the original systematic review report and change their methods, decisions, and analyses that they'd conducted. So some results, what we found at the literature search stage was that the number of records yielded by a database differed by more than 10% for over half of the databases searched. And sometimes the number was vastly different. When it came to screening full text articles and making a decision about whether or not to include a study or not, there was differences between the original review and the replicated review in 8% of the cases. And for the data extraction stage, the study results differed for about 1/3 of the cases for which data are extracted, both by the original reviewers and the replicators. And in all these things, it should be pointed out that sometimes the original reviewers made errors and sometimes the replicators made errors. And then there were also many other reasons why the results differed. When it came to the meta-analyses, of the 10 that we reran, 8 were at the blinded stage, were classified as not fully replicable, in that the original and replicated summary estimate and its CI width differed by more than 10%, but only one of these was classified as being meaningfully different upon replication, in that the statistical significance or direction of the meta-analysis result changed. And then when they reanalyzed the data in the unblinded stage, 5 still remained not fully replicable, but 0 were meaningfully different. And I'll just give you an example of one meta-analysis here. So for example, with this one here, we had for the first, for one of the studies, the data had been extracted from the incorrect time point by the original reviewers, and the original reviewers also included a study in the meta-analysis, despite it not actually meeting the eligibility criteria that they articulated. And so upon replication, we used the correct time point and omitted one of those studies. But if you can see with the mouse here, the overall effect doesn't really change that much. So overall, our findings suggest that the original systematic reviews are not always consistent when their methods are repeated, but their differences are rarely clinically meaningful, and the clearer reporting of various methods would have enhanced replicability. Thank you.
Thank you. Just like to thank tech support, the organizing committee, and also my co-authors, Sarah and Lena, on this work. So I'm sure many of you probably haven't read it, but Australia's 2032 plus high performance sports strategy guides or dictates what we should do in the elite sports space, in particular moving to the Olympic Games held here nationally or locally. For the first time, it brings together over 50 national institutes, national sporting institutes and organizations committed to a single sporting strategy, which is pretty a good thing. In terms of the strategy in my role, I play a particular important piece. Well, I think it's important in terms of fostering world-leading knowledge and practice. So we often rely heavily on the academic literature and in particular meta-analyses to shape and inform some of our practices. This is not always the case, but certainly most of the time. However, we know that in the published literature, and in particular with meta-analyses, they're littered with a multitude of problems, and this is becoming increasingly documented. So a study by Cadillac and colleagues in 2023 looked at 20 of the most highly cited meta-analysis in strength and conditioning research and found that 85% had at least one statistical error, meaning the results are potentially at best inaccurate and most of them are potentially useless. In some more recent work by us, when we looked at a particular subset of meta-analysis, we found that almost all of them were misinterpreted in terms of their results. And so we know there's lots of problems and we need to be aware of this, but one of our challenges is trying to get clinicians and practitioners among the system aware about these things when they're reading meta-analyses. And one of the questions we get often asked is, how do I know that this particular, or the quality of the evidence that this is based on? And probably the answer should be, assume it's not great quality. But it did lead us to ask the question is, how many meta-analyses in sports science and sports medicine actually consider quality of evidence when reporting their results? And I'd just like to acknowledge that this is part of a larger data collection that's helping us to inform a particular paper on this topic. So we looked at meta-analysis studies, recent meta-analysis studies published in 2024 in what I guess is considered highly ranked sports science and sports medicine journal. The data extraction was done on the August 20, and we'll probably update it coming towards the end of the year when there's obviously a full year of publications. So from these articles, we collected information on whether they included a risk of bias assessment and a certainty of grade, also a certainty of evidence appraisal, and whether they reported the results by levels of grade or risk of bias. To help contextualize the results, we also collected some other information on registration, which I won't call pre-registration because it was not always pre, whether they indicated that they followed a reporting guideline, and then also some information on data and code sharing. So the 5 journals are listed on the left-hand side here, and we chose these journals because they're considered prestigious in the field, and also because we know from some data we're able to get from our local library that these are heavily accessed by clinicians and practitioners among the system in terms of downloading papers from these. In terms of journal policies, so we found only one journal that had a mandatory policy for including a quality assessment, but we also noted that they provided no information on what they meant by quality or what tool they recommended for that particular screening. So I'll draw your attention to the results with the orange dots here. So we found that studies generally included a risk of bias appraisal, which is perhaps not so surprising. Less than half of studies assessed or made a grade assessment. And what we were most interested in was that very few, the result of most interest, we found that very few studies actually reported the results by levels of grade or risk of bias. So only 11% there. In terms of looking at individual journals, so we can see that irrespective of the journal policy, risk of bias was widely assessed, which was not the case with grade. And we suspect this is probably more around researcher awareness in the field. And to be honest, probably most researchers aren't aware that grade exists or that it should be assessed for most studies. And then also the need to conduct a sensitivity analysis where the results are considered according to levels of risk of bias or grade. So the main conclusion was that only about 1 in 10 studies reported the results according to some measure of study quality. And so this is something that we're trying to get out to the system in terms of letting practitioners and clinicians be aware of this when they're picking up meta-analyses. What are we trying to do about it? Well, we've just funded a relatively large piece of work looking at the female performance health space, which is a priority area for us. And we want to map not only the amount of evidence, but the quality of it to, I guess, identify where some key areas to do some work is for us. Thank you.